In this video, we are going to talk about how to add, subtract, and multiply set, right? So we are under set. Set is one of the topic in mathematics that is very useful in an engineering field, right? So anything that we are about to do here, if it makes sense to you, that is fine. But if it doesn't make sense, then yours is to just pass and move on to the next level of your education, right? And leave everything for the mathematicians, right? Where they can apply the theory in your daily life. Is that okay? So what exactly is sets over here? Set is something that an irrational number, right? Irrational number. If you don't know what an irrational number is, it's a number. Let me use the word horrible, right? It's a horrible number that has no end. Is that okay? It keeps on after the decimal point. It keeps on, and so on and so forth and so forth. So now they came up with a method that we can use to add and subtract, multiply, just like a normal numbers that we have been adding and subtracting and so on and so forth. Is that okay? So when you have a number enclosed with a square root, right? This is what we call a square root, right? So something like this is what we call a set. Is that okay? A set. So when I print this on the calculator, it will give you something like error, or to give you 0 point something and so on and so forth and so forth. That does not terminate. That's the reason why we normally bring set, so that you can make an easy calculations. Is that okay? So that you can easily write an irrational number perfectly, just like any number that we have in the number system. Now, once again, if, as I say earlier, if it makes sense, that is fine. If it doesn't make sense, just learn the rule, apply them, and then move on to the next level of education, and leave everything for the mathematician to apply their theory in our daily life and so on and so forth. So this is how the set looks like. So anything that's enclosed with a square root, it can be the nth root or cube root and so on and so forth. Is that okay? So anything that is enclosed like this is what we call a set. That is the definition, right? Something under something. Is that okay? So my own definition. Now this is what we call a set. Now let's move on. Let's look at something. What is the functions of the square root? You know earlier on some of the functions of the square root that it mostly splits the numbers, right? The number that you are having, it can split out into maybe 2 and so on and so forth. What I mean by splitting is that when you look at this example here, is that square root of 4 will give me 2. Is that okay? So it is the help of this function, the square root here, this one, that divide this number into, or split this one into two different parts, that the answer gives me 2 over here. So that is the work of this square root over here. Now let's look at the simple form or the basic form of a set. For you to be able to do your calculation perfectly and so on and so forth, you need to reduce whatever you are having into what? A basic form or a simple form. Is that okay? You cannot leave everything just like that for someone to come and continue for you. You have to make sure that you bring everything down to the simplest form. So what is the simplest form of a set? It's a form whereby when you pick that number, you cannot do anything about that again. Just like the square root of 2 that I'm having here, you see, you cannot do anything about this, right? You cannot proceed to have a different answer apart from this square root of 2. That is what I mean by the simple form or the basic form of a set. Is that okay? Should in case I can do anything about this one again, then it is not in what? In a simple or the basic form. Right, so let's look at this. So I'm having a root 8 over here. Is that okay? Root 8 is not in the simple form because I can still break it down. And how do you break it down? By finding what? A perfect number. If you don't know what a perfect number is, then perfect number. Is that okay? So the word is what? A perfect number. So once we are not here on this channel, what we do here is that we help you to identify the image behind the names in mathematics. Is that okay? So the question you should be asking yourself is, what is a perfect number, or who is a perfect number? Right? A perfect number, in my definition, is a number. Of course, the highest number. When I take a square root of that number, it gives me a whole number. Does it make sense? Now let me explain that by this example. Have a look. So 8 here, I'm having 8. So I want to break this 8 down. So what I do is that I'll find a perfect number out of this. What is a perfect number? A perfect number is that when I take a square root of that number, it gives me a whole number. I don't have any answer to be under a square root again. right? So for instance, this root 4 here, 4 is a perfect number. Why? When I take a square root of that one, it gives me what? 2. Is that okay? Another perfect number you can think of is let's say 9, right? 9, is that okay? 9, square root of 9. What the square root does is split this one, right? It will give me 3. So square root of 9 will give me 3. Is that okay? So just pick the numbers one by one, starting from 2. Square of 2 will give me 4. 4 is a perfect number, right? 3 square will give me 9. 9 is a perfect number. 4 square will give me what? 16. 16 is a perfect number, and so on and so forth. Is that okay? So here I'm trying to see if I can get the highest perfect number out of the 8. Of course, that highest number is 4. So when I multiply 4 by 4, it will give me 8. Can you see that? The reason why I brought, you have to bring this one first. Is that okay? So because of the arrangement purpose, so let the perfect number count first. So 4 times 2 will give me what? 8, right? Okay, so that I split the 8 into 2 over here. So what I do is that I divide it under the square root sign. So I'm having root 4 times what? Root 2 over here. Is that okay? The reason is that I want this one can be on its own with the help of this square root sign. Can you see that? Except the 2 over here. So when you are splitting the number into a simple form, you have to make sure that the first one will give you a perfect number, and then the second one is the number that you cannot do anything about it again. Just have a look at this one. I'm having 4 times 2. Is that okay? So when I split this one, I'm having root 4 times what? Root 2. So what happened? Have you seen that with the help of this square root sign, split the 4 into 2. So I'm having a 2 here, whereby the second part, I cannot do anything about it. I cannot reduce it again. Is that okay? So you multiply the 2 by this one, it will give you 2 root 2. So that is what we mean by what? A simple form or the basic form of set. Now let's move on to the main thing here. We are going to talk about the addition and subtractions of a set. Is that okay? Just like a number, normal numbers that we have been adding so far. So what do you do? Have a look at this as first example here. I'm having a root 2 plus what? Root 2. How do you add? That's the question you should be asking yourself. How do you add and how do you subtract? This rule applies to either addition and subtraction of what? A set. So you can only pay attention. Maybe when you are watching, let's say, what you have to do, you need to jot this thing down. Is that okay? When do you add and when do you subtract, so that you know you don't miss them up and down. So what you do here, you can only, so maybe I'll be happy if you can write this example. You can only add or subtract in a set if the number under this set are the same. Is that okay? I see the same person here, I see the same person over here. Under the set. What I mean by the under the set here, this is what you call a square root, right? A number under that has to be the same. That is only when you can add. If the numbers are not the same, there's no way you can add, right? So mathematics is the precise language. You need to obey the rules. Is that okay? Now let's see. I'm having root 2 here plus another root 2 over here. Of course, the rule says that if the numbers under this one are the same, I can add them. Or if they are the same, I can subtract them. Is that okay? So what do you do? Now, you see that here, there's a 1 over here, right? 1 in front of this square root over here. There's also another 1 in front of. So we are going to add 1 plus 1, right? 1 plus 1 over here, and then you maintain the square root of what? One of them, right? So 1 plus 1 will give you what? 2. True? Is that okay? So this one will be what? 2 root 2. Have you seen what is happening? Okay, so perfect. Let's look at the second example. So the second example here is that I'm having 3 root 2 plus 4 root 2. The first question you should ask yourself, can I add these two people, right? Just look at this one to be one number. Can you add them? Under what circumstance do you add them? That is the point. If the number under the square root here are the same, then I can combine the two, or I can subtract them. If they are not the same, then let's leave it like that. Period. Okay, so by the way, here and this one are the same. Is that okay? So what do? You add the outside one, so 3 plus 4, right? 3 plus 4. Then that will be equal to 7. 7 what? Root 2. We maintain one of the root. That is why you need to check whether the number under the square root are the same, right? Okay, so I hope you can proceed from here. So let's see what is happening. So I'm having a root 4 plus what? Root 3 over here. Once again, you need to check whether you can split this one into the basic form before you proceed, right? So always check whether the number is in what? In its basic form. If it is not, convert that to the basic form or the simple form before you proceed. Now, I'm having a root 4 here. I know that this 4 here is a perfect number. That gives me what? 2. What about root 3? Root 3 is already in basic form because you cannot get any perfect number here. That can help you simplify this. Okay, so this one tends to 2, and then I maintain the root 3 like that. Let's look at something. What is happening? So someone will consider or maybe forget one or two the reason for or the rules for adding or subtracting. Then the person will go and add 2 plus 1 over here and then maintain the root 3. Have you seen that this is wrong? Why? Why this is wrong? Why? So maybe comment below. Is that okay? So comment below. Now the fourth one that I'm having here, let's look at the subtraction because this is the only addition that we have been seeing so far. So let's look at the subtraction over here. So I'm having 2 root 8 minus 2 root what? 2. Is that okay? What happened? You ask yourself, are they in simple form? If they are not, make sure that you convert that to the simple form before you proceed, right? So what happened? I consider this guy is not in the simple form. So I'm having a 2. So let's work on the first part before you move on to the second part. So the first part is that 2 multiplied by this. So what I've done here is that I brought a 2 out. So here is a 2. This 2 here, and then I'll work on the root 8. Root 8 is what? 4 times 2. Is that okay? Or under the square root sign. So when you work on this one, you can see that 2 is here. Then you split this one, just like the first example. You split this one into 2. You're having 4 root 4 times what? Root 2. Is that okay? Have you seen that I'm maintaining the second part because it is already in the what? Simple form, right? This is already in a simple form. Then I'm having 2 root 4 times or root 2 minus or 2 root 2. Is that okay? I just do some manipulations on this part, right? So root 4 here will give me 2. Don't forget your 2 outside here. So root 4 here will give me 2, and then this one I'll maintain this one because it's already in what? In its basic form. So when you do your calculation perfectly, you arrive at 2 multiplied by this one will give me 2 root 2, right? And then minus 2 root 2. Look at what is happening. So this guy and that guy. The question is that can you combine them? That is the point. So let's check what is happening here. So I can see that 2 is multiplied whatever it says. So 2 times 2 will give me what? 4 over here. And then 4 root what? Root 2 over here. Right? Minus what? 2 root 2. Is that okay? So what is happening? Here is the point. Can you subtract these two people? That is the question you should be asking yourself. Can you subtract? If yes, under what circumstance? If no, under what circumstance? Right? Here in this case, yes. The reason being is that the number under the square root sign is the same, or they are all the same. Is that okay? Therefore, that guarantees us to add the 2. So we are going to combine. So that will give me what? Outside to outside. So 4 minus 2, that will give me 2. And then you maintain one of the square root. That's what? Root 2. Is that okay? So the answer to this one, 4 minus 2 will give me what? 2 root 2. Right? So if you enjoyed the videos so far, don't forget to subscribe to our YouTube channel, share and like the video. Okay, now let's get to the multiplication aspect. Under what circumstance do you multiply? Right? That is the point. You should know this rule before you can proceed or do anything in mathematics. There are rules governing everything in this world. Is that okay? So let's look at the rule. When do you multiply? Now, in the simple ways, or in my definition or my opinion, you can only multiply outside. This is what I mean by outside to outside, right? And then inside, anything under the square root sign to inside, right? So that's why I'm having this example here. 2 times 2, obviously 2 is outside the square root sign, and then 3 is also outside the square root sign. So they are being combined by multiplication sign. So 2 times 3, right? Outside to outside. Let me put that one into bracket. And then what about inside to inside? Right? So 2 times 3. So they are also going to their destination, right? Under the square root sign. So that will give me 2 times 3. So okay. So for the multiplication, it's outside to outside and then inside to inside. Is that okay? That is quite different from the addition and the subtraction. That's why you need to pay attention to the rules of adding and subtracting set as well as multiplying. So the second example, so I'm having 1 times what? 4 root 3, right? What do you think? Obviously, the first part has no square root sign. So it's just a whole number, right? A whole number, you don't have a square. So this one will be the outside to outside, and then we maintain the inside, right? So that will be outside. So 1 times 4, and then the outside the low, right? Okay, the same thing. What do you think? What do you think could be the answer to this, right? So we have one term in the bracket and then one outside. So the one outside is multiply the one inside. So try your hands on this problem and leave your answer under the comment section below. Then we give you a thumbs up and you mention your name in our next videos. Thank you.